The first thing I'd like to do is point out what our project is. You may have heard of the Trinity River Vision Authority in Fort Worth, Texas. What we have is we have a partnership built with the Corps of Engineers, and we have the existing floodway through the downtown section of Fort Worth. The area right now is, you have a big loop. The courthouse sits about right here. This is the confluence of the Clear Fork, the West Fork, and flows on out of town through the West Fork system here. Right now we have a large area in here that is a very old industrial area. Very low tax base, has never developed much, and it's in a lot of the floodplain problems that traditionally have in low areas adjacent to a river. Our existing floodway, though, we have a levee on this side of the river here, and then also here, and then this is a bluff area there. The problem we've got is we no longer meet the design criteria of our floodway carrying capacity for standard project floods, which is a very large flood. So in order to do that, we've come up with a new project. It's called Panther Island. It used to be called Trinity Uptown, but every city has an uptown area, so just recently we've changed the name to Panther Island. What happens is, by working with a partner with the Corps of Engineers, we're going to build a brand new bypass channel. So we're taking the existing floodway, we're going to build a brand new bypass channel starting at this area within the Clear Fork. The channel is about 300 feet wide, 35 feet deep. So any floods in the future will go down the bypass channel. We'll have a gate here, a gate here, and a gate here. So during floods, those three gates close. By doing so, this area no longer is subject to flooding. Therefore, it opens it up for new development and future use, different from what we have today. But by doing that, you can see over here, our concept is you then can take the area and do a proper planning program and enhance it and entice development to come in for future growth. This is the area that is there today. The existing system is here, the two with the junction of the confluence of the rivers. The bypass channel is here, or will be here once we get it started under construction. We've got three major bridges. This is North Main, this is Henderson Street, this is White Settlement. This project, we combined all three of these bridges. We went out for bids on those three bridges. Our bids were open. We're very pleased. It came in a little bit over $65 million for the construction of the three bridges. Very pleased. It was underneath our engineer's estimate. So we're moving forward with getting those. Hopefully will be awarded at the end of this month. In addition, the local sponsor, the Water District, is required to acquire the property, do all the relocations and the environmental cleanup associated with the federal project. We've already acquired over 90% of this project area. Right now we're at 92%. We've got about 85% of the demolition accomplished, and we're starting our major environmental cleanup this year. But because of the infrastructure that we're being able to put in through the Corps of Engineers, it then opens up again the big loop area here, because the levees are no longer needed. Since they're not needed, they'll be able to come down and you'll be able to have development come up to the river again. Up until now, traditionally in the Fort Worth, we have had our public buildings against the levees, but they face away from the water. They don't use the river as an amenity. It was more of a background with a big levee behind it. Because of this project, we'll now be able to redevelop about an 800-acre island as created by, you can see with the bypass channel and then the river here. Just a quick example, this is just if you were on the north side of town looking down Main Street. The West Fork is over on the right. The bypass channel will come in and it creates the island there. So it gives you a little bit better perspective of what our project is really going to accomplish. Again, this is an architectural rendition of what we're hoping to have. One of the things that we've already accomplished is we've already got a form-based code passed for this whole area. So from that, we're able to control the development and require some kind of infrastructure components that otherwise may not be able to be implemented. One of those that we're very well considering right now is the implementation of LID, what level LID, From that, we wanted to look at a cost analysis of does it make sense to implement it, and if so, what level of LID implementation would actually pay for itself. Just to give you a quick idea of what the project will look like, the left-hand side of the bypass channel is actually going to be a concrete flood wall. It'll be a tiered flood wall. We'll have access down at the water level, and then we'll have public access at the top of it. There'll be a 25-foot setback from the top edge of the flood wall, and then development will be allowed to occur from there back toward the city. It's very similar to other floodway components. The Corps of Engineers will have a review process. You would come to the Water District for approval. We then go to the Corps with the design. Corps reviews it to make sure there's no impact to the flood wall itself, and then with that, the development can occur. The other side of the levee, or the other side of the bypass channel, is a traditional soft levee, an earthen levee. But we're doing it in somewhat of a different manner. We're one of the few agencies in the United States that's gotten a variance for vegetation. We can't have vegetation on the levee. Again, this is an architect's rendition, so don't believe it when it shows you the trees sitting on the levee. It won't happen, I promise you. But we do have the ability to put trees between the toe of the levee. If I can get this guy to show up. Between the toe of the levee here and the water. So, well, it makes a really good picture for selling the project. Believe me, we will not have trees on the levee itself. But it will be a linear parkway. We're designing both a equestrian trail for Fort Worth. That's very important because this area ties into the north side and the stockyards. We have a lot of opportunities for horseback riding. We have it today, and if we cut it off, our project will not be successful. We realized that early on. So we'll have a trail system and a public park system on the soft side. Just quickly, how our project is going to be built. Again, the first thing we have to do is build the 3 bridges. The problem we've got, those are major arteries into the project area. If you build the bypass channel first, you cut all 3 arteries, and therefore you've cut the transportation. So we build the bridges first. It's also cheaper because you build it in the dry, you're not building it over water. The second is after the bridges are built, we then come in and build the bypass channel, which will connect the loop within the system. We have a stormwater management program. Actually, it's in our CDC project component, which most folks in here probably are familiar with, but it's the stormwater valley storage because we're shortening the loop of the river. So therefore, the water is going to move downstream faster, and we're not here to flood our partners downstream or make the water get there any sooner than it would have prior to our project. We then will install the 3 gates I showed you. Those 3 gates will keep the interior from flooding during a flood event. At the north end, you probably didn't see it pop up, but there's a dam here. We're actually going to be building a dam with a lock in it. The lock will tie into Marine Creek, which is this creek here that goes up into the stockyards. The dam will also have a fairly constant level water. I don't like to tell anybody we're going to have a constant level project. I know too well in Texas what happens, especially now when we're not getting any rainfall. But it will at least allow us to control the interior water level. And then finally, we'll have an interior water feature, a little lake, and it's about 35 acres in size. It will add for additional amenity and additional recreational use. That then becomes our new project, both with the Corps of Engineers and as the private development can then start occurring because the project is, the levees are decommissioned at that time, and the levees can come down, and the development will probably start before then, but that's the point in time that the levees can actually be removed. With that, I'm going to turn it over to Scott.
Thanks, Woody. Like you said, my name's Scott Hubley. I'm with Freese and Nichols. And our role in the project, we were developing a stormwater master plan for all the municipal storm drain impacted by the project. And as we're thinking forward to the development, obviously it's, Woody mentioned waterfront development. Water quality is going to be crucial to the success of the project. And so we wanted to think about what could we do with this, on the stormwater side to improve the chances of water quality. And I'm just going to hit a few basics here. Really, when we were looking at it, this is a very high-level analysis that we did, and we really focused in on one LID approach, mainly bioretention. And we said, why would you want to do this, and does it achieve the objectives of promoting water quality in the project? There's a lot of reasons. why you might consider LID approaches. One, it simulates natural processes, the filtration and the biological treatment that happens. That's what nature does, and if we can harness that, that's always good for everybody. Aesthetic benefits, whenever you're going to have landscaping here, when you bring this stuff to the surface, if it's done right, it can look really nice. The side benefit of that is when you bring it up to the surface, people can see it, and you're making the statement to the community that this water quality is important, and so it kind of develops this common understanding that these are the treatment things that we're doing, and it's important to the project. So there's a benefit there. We looked at a distributed LID approach, which generally is going to give you a better treatment efficiency than end-of-pipe solution. So one way you could do it is just run all the storm drain into a pipe and treat it at the end. That generally is not going to work as well as a distributed system of you kind of get a treatment train going where it's going to work a little better. And then it can be cheaper. Green infrastructure compared to gray infrastructure over time can be cheaper. So there's lots of good reasons to look at it. Here you see a picture of Nashville where they have an urban area with the bioretention on the street. As we were talking to the project partners, we brought a lot of examples to say, look, this has really caught on in other parts of the country. Seattle, Milwaukee, DC, Portland. Lots of areas are kind of further along than here, but in our area, Austin's actually got a pretty good jump on this everyone's probably familiar with aquifer restrictions down there, but we talked about these examples mainly just to get some comfort level with the project partners that this isn't some new harebrained idea that's never been tested. There's a pretty good track record. It may just not be right here locally. So I'm going to jump in here to the strategies that we developed, and I'm going to grab this. This is the book that we came up with, and this really what it does, this is, like I said, it's high level. This is really just painting a picture, casting a vision for what we think LID implementation could look like on Panther Island. And we lay out in here a series of alternatives that could be tiered. They build upon each other. And we worked with Verdunity to come up with some images and just kind of keep it. It's a lot of pictures, not a lot of text, not a lot of numbers, just very graphical focused. And as we pass this around, a lot of people really got excited about talking about this concept. The way we have it laid out is that it's basically a tiered approach that builds upon each other. So the base level would be traditional design. This would be business as usual. You always develop as it always has. So there's no green infrastructure in the project. You would collect the stormwater in a system of pipes and treat it through a structural BMP at the outfall, water quality unit, storm scepter sort of thing. The next level up, if you wanted to start talking about LID, where's the best place to start? And so we said right away is probably your best bang for your buck. The comprehensive plan showed street trees along all the streets in the project area. So if we took the idea of what if you convert all those to bioretention, what kind of benefit can you get there? The next step up, if you want to do a little bit more, would be open space response. And so there's some other areas in the project that aren't street right away, but they're under public control. We have some view corridors and some public space along the canals. What if you add bioretention in those areas? This was a big one for this particular project because the goal of the project was not to allow any untreated water into the canals. And so you have a lot of sites that front the canal, but if they can't drain directly to there, they're going to have to go back to the street, into the pipe, down the street through a treatment unit and out. If you add bioretention and LID along the canals, that allows those sites to drain directly to the canals, use the canals as a stormwater feature, and it actually helps you downsize your pipes in the street a little bit. The next one we talked about was what we called architectural response. This is basically what happens on the individual sites. This is outside of public control, and this is kind of a what if. We really focused on just keep it simple. We looked at green roofs. And we said, what if you did 25% coverage across the entire project of green roofs? What kind of benefit would you get? And so I'm going to step through these kind of graphically, and you can see the images that we created. Don Raines at Verdunity helped us come up with these renderings. He did a great job. But this is the right-of-way response. You can see we've got the street trees are in here, and there's a bioretention system. You can see at the bottom of the page There is, it's still connected to the storm drain system. This is not, the clay soils and stuff, it's not going to infiltrate. You still need a subdrain material, but it helps you start kind of decreasing down the impact to your stormwater runoff. You see the number up there, 23%. That basically represents the water quality target for the project. You can achieve 23% of your needs using green infrastructure. So it's a simple number. I'm going to talk about how we calculated that later. But of all the water quality that needs to be treated for the entire development, you could get to a quarter of it by just putting stuff in the right of way. So the next one here, like I said, these build upon each other. This is the open space response. You can see, I'm going to step back so you can see the difference, but we added in the view corridors and along the canals, there's some more bioretention. So here, this is the one where you start having these sites that can drain through that bioretention into the canals. Here you get up to 50% of your water quality needs addressed through green infrastructure. And it's all within public control. So this is the one that we really kind of focused in on, that we think we might try to push it forward. The next one here is architectural response. And so this, again, this is just kind of a vision of what we think the development could look like if sustainable practices and LID really take hold out here. You can see the green roofs. We've got about 25% coverage. There's a lot of other features shown in the map. But again, this is just a picture in our mind's eye of what we think it might look like. Just briefly on the technical side, how did we get those numbers? So the goal here with LID or any water quality treatment is to treat the first flush. ISWIM calls it the water quality volume. So we had that calculated for our project area. With our imperviousness, it was 1.37 inches. And so we delineated in plan view, where do we think we could put bioretention? And we came up with a concept section, and we did the area times the depth and got a volume for the entire project. And then we compared that to the target of 1.37 inches. And you can see the numbers are up there. It's a pretty simple calculation, but we wanted, again, keep it very high level. We're trying to introduce the idea, get people excited about doing it so that we can start moving it forward. The next thing we did, we calculated costs for each of the alternatives. You can see this chart really tells the story. You have traditional on the left, and then right-of-way response, open space, and then architectural. And really the story here, you can see the gray infrastructure, that's your pipes. That cost decreases slowly over time. You're able to decrease the pipe size a little bit by redirecting runoff and slowing down some of the runoff, reducing the peak discharges. But that cost gets replaced with green infrastructure. So you start adding the bioretention. And there is a gap as you go from right of way up to open space. It's going to cost a little bit more. There's more areas that we weren't necessarily planning on putting it, and there's going to be some costs incurred with that. But that's where Wilkins, Mike Wilkins with Verdunity came in. We asked him to help us look at how do we address that gap, and will these things actually pay for themselves? So with that, I'm going to turn it over to him.
Thanks, Scott. Good morning, everyone. Yes, so we've looked at this project in a different way. Instead of planning for traditional gray infrastructure implementation for stormwater management, we looked at this right mix of green infrastructure and gray infrastructure in different ways. And what we showed pretty clearly was we can start to manage the stormwater in a different way and do so to meet those water quality expectations for the development. At the same time, by doing this in the right of way and open spaces, we're lessening some of that burden on the individual sites as they develop. So we're showing that environmental benefit, and the first question that Woody asked me was, how do we explain this gap? How do we explain why we're going to spend more on green infrastructure than traditional infrastructure? And that's where the business case evaluation comes into play. The stormwater business case evaluation allows us to quantify all the tangible economic, social, and environmental benefits associated with the green infrastructure implementation project. The business case evaluation is a life cycle analysis tool. It's being created by Impact Infrastructure. And this is tied in, I needed to skip excuse me. There we go. This tool they're developing is tied in with the Envision rating system from Institute for Sustainable Infrastructure. The first module they created is the Green Infrastructure tool, which basically allows you to input all the different costs and calculate the intangible benefits that are related to the economic side and the social and the environmental side. So this is what the business case evaluating tool does. Impact Infrastructure presently is creating these tools for all transit, bridges, and highways as well. So the end game is they're going to have a system that you can look at all these economic impacts over the life cycle of a project for any type of infrastructure project. The name of that tool is going to be called AutoCase, and eventually it's going to be integrated into AutoCAD systems Civil 3D. So what I want to describe, I'm going to skip this one and come back to it. I want to describe the costs that go into this model, the first things that we look at. The first, obviously, is the capital cost, and we looked at the probable construction cost that was estimated by F&I just for the stormwater infrastructure. We estimated this infrastructure would be built over an 8-year period, and we assumed a 50-year operational period to start looking at those life cycle costs and benefits. Operations and maintenance costs. The model has built into it the national database for BMPs and green infrastructure. So the neat thing is you can pick out the high end and the low end for different types of BMPs, such as bioretention, in terms of annual maintenance costs, and it's tied into the area and the amount. And you can run the model, and it gives you a certain assurance that your annual costs are going to be within a certain range. But then you can go in and you can look at your actual data that you have locally, and you can start to tweak that data to make sure that you're telling the right story. Because that is an added cost. There is going to be an added maintenance cost that you need to be aware of. So what are the benefits? I'm sorry, my slide got mixed up a little bit. The first benefit we looked at was the estimated boost in the sales tax within the development. And there are plenty of case studies that show in a quality development that has quality green space, open space, and accessible clean water features, you can expect an increase in your annual sales tax revenues. Most of the studies and the case studies show that you can expect a 10 to 15% increase in those revenues. We want it to be very conservative. You know, I didn't want to come in and say, yes, if you do it this way, you're going to get 25% more sales tax increases. Because a lot of this hinges on the health of the economy and whether or not it develops as quick as we expect it will. So we wanted to be very, very conservative. And we estimated for the right-of-way response, which is that limited LID implementation, that we would see about a 2% increase in annual sales tax revenue from the retail establishments. For the expanded implementation that goes into the open space and into the canals and the lakefront, we're estimating a 4% increase. So again, we're just tweaking it up based on the coverage of these quality green space and accessible clean water feature areas. Now, where did that sales tax information come from? It came from a study, I believe it was in 2005, from the University of North Texas, where they projected the sales tax revenues for the Panther Island development over its life cycle, and that was just based on traditional development as we've done it in the past and as we're going to continue to do so today. We took that data, we brought it back to today's dollars and projected those increases within the model. I apologize for skipping due to my mixed up slides. The next benefit that we looked at, and probably the one that's gonna push us over the top, is the property value benefits. Now what we did is we estimated this based on information provided by the Trinity River Vision Authority, where they project that they'll have 10,500 residential units in this 329-acre development when it's all said and done. The average value of these residential units is projected to be $155,000. So again, we wanted to be conservative. If you look at a lot of the case studies, and a good example is if you take any given neighborhood and you pick, let's say, a 150,000 square foot house that's sandwiched between an alleyway and a large street, and you pick that same model of house that's close to an accessible green space, open space, a clean water area, you're going to see a gigantic jump in that property value. And so that's kind of the background to it. You can expect, realistically, 10 to 20% increases in property values for those that are close to those natural amenities, those nice open spaces. We didn't estimate a 10 to 25% increase. We kept it at 3.36% increase in property values for those specific properties that would be directly impacted by the level of implementation. So the first that we looked at was the implementation of the right-of-way, and we estimated that out of those 10,500 residential units, 2,100 of those units would be affected. That estimated total value added, net present value for the right-of-way implementation turned out to be $2.9 million, so almost a $3 million real monetary benefit for implementing LID to that level. Expanding to the open space response, we estimated that we could double the amount of residential units that would be directly impacted, and that net present value benefit turned out to be $5.8 million. So there's real dollar amounts tied to doing this, and there's lots of case studies that will back it up. And again, being conservative, I think we could actually expect to have even more benefits than what we've shown in the report. The other benefits that are tied to dollars are those intangible benefits, and those are the ones that are related to water quality improvements. And the water quality improvements portion is really the willingness to pay. How do you determine what people will pay for quality water in a quality space? And an analogy I can use for that is if you're going down the tollway and your first free exit will let you go to a nice area, but you can only sit on the bank and have a picnic. If you go a little bit further, maybe 10 miles further down the tollway, it's going to cost you $1.50, but when you exit, you've got a nice open space where you can swim, kayak, do all those kinds of things. So that's that willingness to pay concept. A little intangible, but it's a real monetary benefit. The others are the carbon sequestration benefits and air pollution reduction. People will pay more, businesses will pay more to be located in an area that has cleaner air and really more walkability and a better quality of life. So the end result is we compared both of these levels of implementation. The right-of-way response, when you factor in the additional capital costs and maintenance costs and factor in all these benefits, there's a true net benefit of $3.5 million for this level of implementation, and that's today's dollars. If you look at the open space response, which is going to take another $1.6 million in capital investment, which is the big question that we had to answer, why do we do it? We want to do it because there's a real value of $5.5 million to doing that. So the business case evaluation tool gives you a robust model to where you can look at all these different alternatives. It can actually just be a street that you're looking at. It doesn't matter how small or big the project is, but it gives you a really quality planning tool that gives you those benefits and costs, all of it in real dollars that you can convey to your councilmen, your city leaders, and help really move these efforts forward. So where we're at now, and Scott mentioned a lot of this, just to sum up, we had this vision for Panther Island. How can we implement LID and start things going? We took that 50,000-foot view, and now we've completed this business case evaluation, which answers all the questions with real dollars. And so next, we start to look at more in-depth engineering planning. We look at the funding resources, we look at developer resources, and operations and maintenance. So with that, I'm going to shut us down here and open it up for questions.